All right, hello. Today we're going to be talking about multiplexers. Here, right now, I'm showing is the most simplest form of the multiplexer. It is a 2-to-1 multiplexer. What a multiplexer does is it will select one input path, either D0 or D1, and have it be set to its output. We have the selection input here to dictate whether we want D0 or D1. So for example, set to 0, if we have D0 set to 1, we'll have a 1 and a 1 going through this AND gate, and it's going to transfer out to be 1. Say if we wanted to transfer out D1's input, well, we just take the selection, set it to 1, and then we get D1's output here. You can see no matter how much I change D0, nothing happens, but when I change D1, we get the output to change, and vice versa. So we can expand on this idea to build a 4-to-1 multiplexer, as shown here. So now we're going to use 3 2-to-1 multiplexers as our building blocks for this 4-to-1. All right, so you can see we have 4 inputs here, and then this time we have 2 selection inputs here. It's worth noting that the number of selection inputs is dictated by how many inputs you have. The equation is 2 to the n power equals how many inputs you have. So 2 to the n equals 4 inputs. That means n, our number of selection inputs, will be equal to 2. So that's why we have 2 up here. All right. Now this S0 input selection here will dictate whether we have D0 and D2 pass on, or if we have it set to 1, we'll have D1 and D3 pass through these inputs here. And then this S1 switch here will dictate whether those results, one of those results get outputted. So for example, we have 1 here, that's going to be D1 and D3 be outputted, and S1 set to 0 is selecting D1's output to be outputted. If we set this to 1, then we get D3's output here set to 0. And as you can see, I could change that to a 1 and the output changes to 1. But if I change anything else, it doesn't matter. We're only selecting D3 to be outputted. So now we can even expand on this further by building an 8-to-1 multiplexer. All right. And now for this 8-to-1 multiplexer, we're going to need 3 selection inputs here. All right. For the building blocks, we have a 4-to-1, 2 4-to-1 multiplexers, and then both of those get outputted and summed into this 2-to-1 multiplexer to select the output. Now this S0 and S1 switch here, they act a little bit differently as they are weighted binary now. The most significant bit being S1 here and least significant bit being S0 here. So for example, if we wanted to select switches A2 and B2, then we insert a 2 here. And now we have A2 pass through here and B2 pass through here. And now if we set this to 1, S2 will dictate whether A2 gets sent out or B2 gets sent out. So right now, this set to 0 is letting A2 pass through. B2 doesn't change anything unless we have its S2 set to 1. And now B2 will change. And as you can see, no matter what else I change, it's not going to change the output. So say if, for another example, I want to output A3, I insert binary 3 here, and I select S2 to be 0, and now A3 will be outputted, as you can see here in this output as it changes. So that is how that works. So now let's test something a little bit different. Let's go to this 4-bit 2-to-1 multiplexer. So this multiplexer looks very similar to this 8-to-1 because there appears to be 8 inputs, but we only have 1 selector input here. All right. So what's going on here is that A3, A2, A1, and A0 will either get outputted or B3, B2, B1, or B0 gets outputted. It kind of reminds me of the 2-to-1 multiplexer. However, instead of choosing 1 input bit to be transferred out, we have 4 input bits being transferred out at once. So say if, for example, A3, we want to output 1, 0, 1, 0, we have 1, 0, 1, 0 here. And say for B, if we wanted to output 0, 1, 0, 1, all we had to do is flip the selector switch, and then we get 0, 1, 0, 1. So that is simply how this 4-bit 2-to-1 multiplexer works. And it's very important to state how many inputs and output bits you have because, well, you don't want to have only one be outputted to a 4-bit output. So it's always important to state how many inputs and outputs you have for your multiplexers because they come in all shapes and sizes and inputs and outputs. So that is all, and thank you for watching.